I'm really excited to talk to you about some ways that we can create more performant VR experience for the web. My name is Erica Stanley, as Katie mentioned. I work on the mixed reality team at Mozilla. So that's actually a combination of several different applications that work with augmented reality and virtual reality. I work on the Firefox reality team, and we are mostly focused on virtual reality right now, even though we do have some augmented reality offerings. But we also work with a program called Hubs. We work with Servo. All of those components are part of the mixed reality team. And the mixed reality team is a part of the larger emerging technologies organization. And this is just very cool to me because I've always been interested in that intersection of emerging technologies, kind of cutting edge technologies and social science. So how do these brand new technologies or technologies that we haven't really explored a lot, how do they affect how we engage with each other and how we communicate? And so before we go too much further, what is mixed reality? So let's talk about virtual reality first. Users are completely immersed in a computer-generated reality when they experience virtual reality. Virtual reality is the most well-known of immersive technologies. While the world of gaming and entertainment were early adopters of virtual reality, VR applications are now used in many organizations and industries, including the military, engineering and construction, healthcare, education, business, and more. When a user puts on a head-mounted display or a VR set, they sense and their brains believe they are moving among virtual objects on a screen. Most commonly, the headset is connected to a PC or a console. In some cases, you're using your phone, and this enables the virtual experience. In the case of Google Cardboard or Samsung Gear VR, Google Daydream, you're going to be using your smartphone. You're also using your smartphone when you use something like Oculus Quest. The initial setup is through your phone, but then it's a standalone device. And so it's the smartphone that creates that virtual experience, except in the situation of the Quest where it's a standalone device. AR technology is a little bit different. This is technology that overlays digital information on the real world. Rather than provide a fully immersive virtual experience, augmented reality enhances the real world with images, text, and other virtual information via devices such as heads-up displays, smartphones, tablets, smart lenses, and AR glasses. Mixed reality is where you're combining the two. So where does it fit on kind of immersive technology spectrum? It goes beyond augmented reality because users can interact with real-time objects and virtual objects that are placed within that real world. These virtual items will then respond and react to users as if they were actual objects. In order to experience mixed reality, an MR headset is used. MR headsets offer holographic experience through translucent glasses or immersive experience. So you want to think of something like the HoloLens when you're thinking more of mixed reality. So I mentioned earlier that I work with the Firefox Reality team, and we are actually two teams. We have Firefox Reality for Windows, which is pre-release. We haven't officially released that yet. And then we have Firefox Reality for Android, which you can get on just about all Android devices and also comes on the Oculus Quest standalone browser or standalone headset. And so I mentioned before that Firefox Reality is part of mixed reality, is part of this emerging technologies team. So this is a research team at Mozilla. And I think a lot of people think that when you're on a research team, you probably are not super focused on performance. They might think that you're focused on getting something working or prototyping something as quickly as possible. But performance is really important in virtual and augmented reality applications. So we want to make sure that at all times we have a high frame rate, that immersive video playback is high quality, and that we are responding really well to any of the controller events or head and hand tracking. The reason that we want to make sure that we're doing this, the reason why performance is so important on VR applications is because this actually contributes to not just to the user's experience, but to the user comfort. If we are dropping a lot of frames so that we don't have a high frame rate, say something above 60 frames per second, and you really want to have as high a frame rate as possible, even going as high as 90 frames per second. But once you start to dip below that, you cause a lot of discomfort for the user and a lot of kind of jumpiness in your application that can actually make your user sick. So if you want to really see how you can push the envelope with virtual reality, which is the goal of a research team, you also need to make sure that you are focusing on performance. And so some of the applications of VR also kind of uh, lend themselves to high performing environments. And so you think of some of the applications of VR. Telemedicine is very big right now with the need to socially distance. And so being able to do that in a way where you can interact and where you can see the person that you're talking to, but also maybe see their movements and maybe interact in a different way is very interesting. A lot of kids are learning virtually right now, and so there's a lot of applications with education as well. There's actually a team I work with here in Atlanta that was originally based in Oakland called WebXR that works to help make sure that kids get exposed to all kinds of amazing experiences through VR. There are also sports applications, obviously simulations and training, 3D modeling, gaming, and social and collaboration. And so this is really interesting because we actually recently partnered with IEEE VR to bring their experience of this huge VR conference to Hubs, which is Mozilla's social VR platform. And the need for this came about because of the need to implement social distancing. And so they had to take their conference, as we are doing right now, they had to take their conference online. And we were trying to find some different ways that people could interact and not just kind of listen to, say, a video presentation. How could we make this a little bit more engaging and a little bit more interactive? And this was kind of the perfect time to prototype how an event like this could work in VR, because with it being a VR conference, a lot of people would have been really interested, would have had headsets, would have had the equipment necessary to do this. And so this was the first prototype of an event of this kind, and it went really well. And as you can see, this is just a picture, a screenshot of one of the sessions going on during the conference. And what's also very cool is there was a different section for sponsors. So each sponsor had their own custom virtual environment that they could customize in any way they wanted. And as a conference organizer myself, it's really interesting because technically you could have unlimited sponsors and have unlimited space for sponsors at your virtual event. And each room could be different and branded in a way that makes sense for that company. But as we're diving in a little bit more on why performance is so important to virtual reality applications, let's dig into how VR actually works. So headset devices use stereoscopic displays to make what you see three-dimensional, and to give the image depth in a similar way to how our eyes see naturally. But a headset alone does not make a fully immersive experience. It only becomes immersive when we can track a user's motion, head and eye movements, so that when the user turns their head, the environment changes too. And this is super important because if it does not change with the head motion, first of all, it breaks kind of the suspension of disbelief that's necessary for an immersive environment. But again, it can also contribute to making the user sick. And so we take that tracking one step further. In a truly virtual experience, the user should be able to interact with objects in the virtual world, as well as move forward and backwards and really explore the environment that they are working in. When you can see, move, and interact and sense in this virtual world, our brains perceive that as real experienced information. So we're starting to understand why performance in a virtual reality environment is so important, but what are some of the common pitfalls? So we mentioned low frame rate can be a huge one. Low resolution can be another. Again, can contribute to some discomfort, but can also just remove that kind of sense of uh, believing in the environment. You can also have anti-aliasing issues that make some of the images and some of the objects and text in this world appear jagged. And then you can have kind of a distorted scaled textures where maybe you have very large textures and the application is scaling them down to something that is reasonable, but in that scaling down, it actually distorts the textures. But then we also need to think about some of the social concerns that come with VR applications and how performance can affect those things. Things like accessibility. How are people going to be able to interact with your application if they don't have full mobility? If they don't have full use of sight or hearing, how will they be able to engage with and interact with your application? That's something that you have to take into consideration. And then privacy concerns become even more important than some of the ways we see privacy um, uh, become important on the web, typically because there's so much more information that you're gathering from a user. Things like height, things um, like any kind of accessibility concerns, all kinds of things that you can gather about a user that you would not normally be able to gather if someone is just using a web application. So we have to be sensitive to those kinds of privacy concerns. So let's talk about some just general best practices for virtual reality environments. First, you want to optimize for the user's comfort. It really doesn't help to have a super um, high quality environment if you are dropping frames and that causes the user some discomfort. So some of those artifacts are worse than others. You also want to make sure that you're running a profiler to understand the way your application is using resources. Because there's so many different headsets. Headsets are kind of in that early stage of smartphones, maybe 10 years ago, where there was a lot of fragmentation. And so one headset will affect your system very differently than another headset. And so you always want to run a profiler with a new system to understand the way your application is using your resources. You want to limit your time spent in script, JavaScript, or any other logic. You want to limit that execution to under 3 milliseconds. Um, you also want to be using as few textures as possible. You can use large textures, but if you can minimize the number of textures, the number of images that you're having to load, that helps a lot with performance. You also want to make sure that when you're optimizing, you change one thing at a time to isolate issues. So you really want to be able to see, like, is the issue that you're noticing, is this a resolution issue? Is it something with your hardware resources? Could it be image quality? You want to change those individually so that you can actually isolate what your issue is. And then again, you want to understand your bottlenecks. What's really interesting is for some of the headsets that are connected to PCs, a lot of times the CPU is not the bottleneck, it's actually the GPU on those devices. So understanding your bottleneck can help you design your application to be more performant. You also want to use ways of kind of minimizing drawing and minimizing computation. And so use level of detail. So that means as you look further back in your environment, you should not be able to see the same kind of really high resolution detail that you can see on objects that are closer to you. Culling is when you do not render objects that are occluded by other objects within your view. And batching techniques, like how many things can you draw at the same time to reduce your drawing calls. And so let's talk about some of the standards on the web that are really kind of empowering VR. So WebGL is probably the first, and it's a cross-platform, royalty-free web standard and API for low-level 3D graphics based on OpenGL. So WebGL has been around a really long time. We're actually, a lot of browsers have support for it. We're moving into WebGL 2. But WebGPU is actually a new API draft that's not fully supported yet. There are some browsers. Firefox Nightly has some support for WebGPU, but it's a new API draft that's aimed to give 3D applications a lower level API than WebGL and provides more functionality and improved performance. It's something that people think could help the web close the gap with native 3D engines. And then you have WebXR. WebXR is an API that allows web pages to interact with virtual or augmented reality devices to perform all kinds of things, such as getting the position and rotation of a device, displaying an image on that device, handling any of the events from the controllers, such as like a joystick or a button, and getting the position and rotation of the controllers themselves, and then querying the AR and VR capabilities of that device. Some common frameworks that build on top of these kind of foundational APIs are Babylon.js, which is probably the most widely used at this point. Three.js is maybe the most well-known though, because it's been around a little bit longer. And both of these kind of tap into WebGL and make that a little bit simpler. A-Frame takes this even further and creates a markup language for creating 3D scenes. And then Spectre.js is a debugger for WebGL. So now, given that these are some of the tools that people are using to build virtual reality applications, are there certain performance optimizations that we can target within these tools? So let's look at 3D optimizations. And when we talk about 3D optimizations, we're likely talking about using WebGL or any of those frameworks, Babylon.js, Three.js, A-Frame, that build on top of WebGL. And so when you're thinking of 3D optimizations, you want to make sure that you keep the topology of your geometry regular. So if you look at this image, the image on the left actually has pretty regular usage of polygons, and on the right, you have very irregularly shaped polygons that make up this pretty regularly shaped image. So you can probably reduce some of that irregularity. You want to increase polygons whenever the geometry turns, so at any of your corners, to really make sure that your geometry is smooth and not distorted. You want to make sure that you are avoiding excess detail. If you notice in the illustration here, we are accomplishing the same look and feel on the left side without nearly as many polygons as we are using for the cutout section. If you can see my mouse, for this cutout section here, we're using far more polygons on the right side than we are on the left side. So we want to remove that excess detail. Again, as I mentioned before, you want to reduce the amount of images that you're using. And so one way to do this is to use vertex colors instead of images for any of your vertices. So what you might want to do is create more geometry to account for certain boundaries, as you see in the right side here. And so multi-view is actually a WebGL extension that actually helps make a lot of amazing changes and optimizations for WebXR. So when VR first arrived, many engines supported stereo rendering by running all of the render stages twice, one for each camera or one for each eye. And while it works, it was very inefficient. And even if we are able to reduce the number of state changes by maybe switching programs or grouping up objects and batching, the number of draw calls still remains the same, 2 times the number of objects. So in order to minimize this bottleneck, the multi-view extension was added to WebGL. Multi-view allows you to use just one draw call to draw on multiple targets, reducing the overhead per view. This extension can be used to improve multiple uh, tasks, such as cascaded shadow maps, rendering cube maps, rendering multiple viewports as you might in CAD software. But the most common use, especially for WebXR applications, is for stereo rendering. Stereo rendering is also kind of our main performance target there, as this will improve the VR rendering path performance with just a few modifications in any 3D engine. Currently, most of the headsets have 2 views, but there are prototypes of headsets with ultra-wide field of view using 4 views, which is currently the maximum number of views supported by multi-view. And you can start using this feature right now. Firefox Desktop has it. Firefox Reality has had it since version 1.3. Chrome also has it, and the Oculus browser on their standalone devices also has it, but it's not enabled by default. So you'll have to enable that. And as we look at some of the benchmarking for this, for stereo rendering with 2 views, we see a consistent improvement of 40% compared to traditional rendering. And as you can see on the following chart, the more draw calls you make, the bigger your gain in performance. So in conclusion, you really want to make sure that you are optimizing for your users' comfort, accessibility, and privacy first and foremost. You want to simplify your scenes, simplify your geometry. You want to do whatever you can to reduce your drawing calls. And then you want to think holistically about how to optimize throughout your graphics pipeline. It might be something in WebGL that you can optimize. There may be something in your WebXR application that you can optimize. There might be something even lower level. So you want to think about your entire application and the entire system as you are finding ways to optimize for virtual reality applications. And here are a few of the resources that I want to share with you. And thank you. And let me know if you have any questions.